Hey, we've got it. We've got
I
Alexa.
just asked if we were going to join the call today.
Sorry, I didn't have my headset on.
Oh no, yeah, Mr. Bergwadia. There he is.
How are you?
I've got electricity at least for the moment.
I was gonna ask about that. Yeah, I know it seems like a rough week or two,
Yeah, it's been
to say the least.
yeah, we've well, a lot of the people on this call have already heard me complain about it, so I'm gonna keep my complaints to a minimum. It's just so easy to complain. That's the thing. It's
Oh.
but yeah. Dare I ask how the weather is out there in California?
I haven't looked outside. It's a little bit cloudy, no sunshine yet, but probably later in the day. Can't
That
complain.
makes me feel a little
Yeah.
bit better. That's good.
Yeah.
Nice. All right. Very good. Jim is with us. Okay. I get to harass Jim publicly. Any chance I get, I'll do that. That's
Not a problem.
oh, very good. Okay. Well, we've got about 10 or more folks on at the moment. We should have about twice that or more, I expect. So in the meantime, I think all of you who are on, except for Mr. Kalansky, Bart, there he is. Bart, is this can't be your first time on?
Hello.
There he is. Hey, Bart. Hey.
How are you doing? It is my first time on, actually.
Okay. All right. Okay, Bart. While we're sort of waiting for others to filter in, there's a tradition, and it is to say hi to everybody. Give a brief introduction, if you would. Kind of say a few words.
I thought you were going to ask me to sing a song.
That works too. Yeah.
I would honestly rather not. No, but so, well, my name is Bart. I've been coding for about 12 months. I'm being made redundant due to the company that I work for. They're moving operations to America, so I've been kind of looking to change careers. And about 6 months ago, I've wanted to join in with the Hacktoberfest and start to help out with the Layer5 stuff. I've been enjoying it so far. But yeah, it's nice to get involved into a Zoom call. And hello, everyone.
Nice. For the, I guess for the culturally non-diverse, educate the rest of us on the accent, on where you're.
So I was born in Poland, but I grew up in the UK. So my accent's mixed. I grew up in the south of England, and I moved to the north of England for university. So it kind of goes all over the place, but.
Nice, good. I don't know if you, Bart, you may know this already, but just word to the wise, like here in the U.S., I think Jim might back me up on this. Is automatically, if you have a British accent, it's an automatic 10-point add on your IQ. So we just assume that you're, erudite and carry a PhD behind your name, and so
every little helps.
I'll take 10 points. Boy, I could really use a half a point. Yeah. Nice. Good, Bart. It's kind of funny to have you introduced, because you've been in the community for quite some time. Actually, great day for you to join on the call because of something that you know very well, which is that the Layer5 website, the one that you guys have been working on for, I don't know, wow. Was it July, we started talking about Gatsby and switching off of Jekyll, and And hey, it only took 155 contributors in 6 months. But thanks to Bart and others, it's obligatory. Like if you haven't seen the site lately, like in the last 12 hours, then you haven't seen the site. It's just what a marvel this is. There've been a few people who've been here in the trenches on this effort for a while. And I'm seeing a lot of their names on here. I hesitate to even call them out by name because there's 150 others that have contributed. But it's if I can say so, other than the occasional picture of this freckle-faced individual, it looks pretty fantastic. It's looking amazing. Go check out your profiles on this thing. This is funny. I was just chatting with Ed 2 minutes before the call. He's out here in Austin as well. That picture is from one of our meetups, actually. We've got the usual suspects here, but go check it out. I think you all should be patting yourself on the back. I think you've got something here.
Looks great.
Yeah, I could just sit here all day. I could. Well, you know what we're missing though is this. I don't see a Caverno picture on here. I don't know what.
Not yet.
Nice. Oh, good. Okay. Well, one other announcement, I think, and then we're going to talk. We're going to hear from Jim a lot today, hopefully. So the other announcement that we talked last time we met. We talked about. Well, actually, before we do that, so welcome everybody who's new who joined the community from last week or since the last time we met. Anyone other than Bart, first time on this call? Nope, I don't think so. So last time we met, we talked about the notion that there's a handful of us that are delivering a workshop at IstioCon on Monday. And one thing that I didn't note that I should is that if any of you are, so as we go to deliver this workshop at IstioCon, there's an open need for lab assistance for folks who, like yourselves, who either have familiarity with Meshery, because we'll be teaching people about Istio using Meshery, like usual, or if you have any familiarity with Istio, or just one or the other, ping me, and let's get you on as let's get you into the workshop. I'm hanging out as lab assistant to help people. I recognize many of you. There's a lot of you that are probably thinking, "Oh, maybe I could stretch to help there. Maybe I could," but you feel pretty uncomfortable because you know that there's a lot of things that you don't know. No, here's a good chance. Here's a good chance to stretch and grow. Even if all you're familiar with is just common pitfalls that people have when they go to set up Meshery, that's enough. I mean, you know, that no doubt people will run into those pitfalls. And we should be taking more notes on what those pitfalls are to make sure that we overcome them. So good. So that also means that, so this is happening, I think it's about noon Central Time, which I don't think it won't impact our website's call on Monday. So that'll still go on. So as a prelude to the website's call on Monday, I suspect Augustine he's got a list that he's compiling of various tweaks to be made on the new website. There's a few of them, just some small inconsistencies, you know, between, well, I won't even begin to list them. There's just a number of small inconsistencies that I think we're probably going to want to go through and clean up some. So good. Okay. Final item before we talk about Caverno, and that is Manuel, Mr. Moran. Manuel, are you? Can you hear me? Are you on the call?
Yes, yes, I'm on the call.
There he is. Good. Hey, it's a great day whenever a Docker captain joins the community. So,
Thank you and to all the team. It is a great job.
yeah, Manuel, if you would, we made Bart suffer just a moment ago. Bart Kalansky, he's on the call, and he had to introduce himself because it was his first time on the call. And so, Manuel, do you mind just doing a quick introduction and telling people about you a little bit?
Okay, maybe you hear some noise because I'm out of the house, out of the office, so that's why I'm not using my video.
Got it.
Okay, but it's not a problem. My name is Manuel. I'm really enthusiastic with cloud native architectures and everything around containers and workflow around, say, CDC, continuous integration, continuous delivery. I'm part of the Docker Captain team. My position in the community is try to help to everybody to join to the team and try to grow really good architectures in our company, so on our team. So I saw that this is a really good program to help others, and that's why I'm here and try to put my hands to help to everybody.
Well, it doesn't. And I thought I thought Bart's introduction couldn't be topped with his English accent. But Manuel, that's beautiful. I just welcome. Very, very pleased that you're joining.
Thank you.
That's awesome. Yeah, and by the way, the background noise is almost non-existent. Like it's yeah. So nice, good. Okay, well, Jim, we just keep eating into Caverno time. Like we just
No worries.
Well, with that, yeah, let me be quiet and say, hey all, I talked about Jim the last, I think the last couple of weeks now. I've mentioned that Jim has had the, well, the great pleasure of knowing me for a number of years now. He and I got to spend some time at Cisco together, and Jim went off and founded a company. Jim, do you want to tell people about Nirmata and Caverno and?
Yeah, absolutely. And if I can share my screen, I'll also pull up a deck as we go through. So, hi everyone, pleasure to be here. Thank you for having me. I'm Jim Bagwadia, co-founder, CEO at Nirmata. So, like Lee mentioned, kind of a little bit about myself and just history and what we do at Nirmata, and then I'll dive into Caverno. So, like Lee mentioned, we started Nirmata pretty early in the cloud native space, right? So this was even pre-Kubernetes, for those of you who remember such a time. So this was, when Docker was just emerging out of .cloud. And our whole kind of thinking and what we do at Nirmata is help enterprises manage cloud native applications, right? So my background is in operations and management. I've built network management type systems in various domains like device networking, telecom, wired wireless communications, things like that. And what we saw is, of course, as every enterprise becomes a digital enterprise, there's a need to manage software with the same discipline, with the same kind of technologies that we've used in other mission critical domains, right? So that's what Nirmata does. But here, what I want to talk about is one of our CNCF projects, which we're super excited about. And there's been a lot of great adoption in the community. And I think the one interesting thing about it is how what I'll discuss with Caverno, how it also intersects with other projects and other things happening in Kubernetes, right? So we're already partnering with other communities like Data on Kubernetes, where with OpenEBS and other technologies on the storage side, we're in discussions with even Cert Manager for identity management and certificate management for workloads. And another, of course, very interesting area, which we want to explore and understand the use cases and and see how Kyverno may fit into, is with service mesh and managing different aspects, whether it's security related or even automation and other things, other concerns which cluster admins may have with installing operating service meshes. So anyways, let's dive into Kyverno. I'll go through a few slides to just explain what it does. We'll look at a hands-on demo or two, and then we can just have an open discussion and conversation. Okay, so why Kyverno, why policies? So let's just start there, right? So first off, Kyverno means govern in Greek, right? So we thought it's a good fit for given the theme with Kubernetes. Kyverno is talking about governance for for Kubernetes, right? And it's as opposed to a lot of you may have heard of OPA Gatekeeper, which is another very popular policy engine, which was designed for as a general purpose policy engine. So it works with other systems as well. So there's some interesting trade-offs to consider if you're are looking at a policy management solution, because Kyverno is designed for Kubernetes, can fits in very well with the Kubernetes way of doing things, whereas OPA Gatekeeper is trying to, or OPA specifically, is trying to address policy concerns across multiple systems, and then Gatekeeper brings in OPA into Kubernetes. So both can do very interesting things, but it's a trade-off as you're kind of evaluating and selecting. So before going deeper into again Kyverno and what that does, it's important to understand why bother with policies at all, right? So why look at policy management versus just dealing with Kubernetes configs? So the one thing a lot of folks may have heard is Kubernetes configurations are declarative in nature, right? And what that means is you're telling the system your desired state. You're describing what you want, and then the system, has a bunch of controllers that go off and work very hard to bring the actual state to that desired state, right? So that's how declarative configuration works. But what that also has a side effect of doing is there's an explosion in configuration, right? Because you want to be very precise about describing the state that you want, because you're not instructing the system step by step to do a series of tasks. You're just telling it what you want. And the better you can be in describing what you want, the better the outcomes. So Kubernetes configuration tends to be fairly detailed and complex to some degree. And configuration also tends to address many different concerns. Like if you think about a Kubernetes cluster or any Kubernetes resource, you have the operator view of things, you have the workload owner or the developer view of things, and then perhaps you have others like auditors and people who are dealing with security. And so you have several different views of a single resource, and configuration and status and stuff has to cross-cut across all of that, right? So this also adds another layer of complexity and another layer of challenges when you're managing Kubernetes configurations. Policies are great at solving these problems, where they can simplify, what a developer needs to do versus what an admin needs to do, and they can also kind of separate those concerns. So you can restrict, for example, what can be changed in certain workloads in certain namespaces. You can enforce defaults. There's many such use cases that get enabled through policy management. So with Kyverno, the approach we have chosen is, to again make policies very natural to Kubernetes admins. So adopting the same declarative nature of Kubernetes configurations, making policies very easy to write and manage using standard tools, and also making policy results very easy to view, manage, and work with, right? So, and of course, we want to make sure that we support not just the native Kubernetes resource, but any resource. So internally, Kyverno uses the dynamic CRDs and dynamic, kind of informers and things to that nature to be able to deal with any Kubernetes resource, including custom resources that are not, defined in the native API schema itself. And then in addition to that, one of the key approaches with Kyverno was to adopt all of the Kubernetes best practices, and patterns like label selectors, owner references, pod controllers, events. So everything you would expect out of a Kubernetes resource, Kyverno also adopts the same kind of philosophies and implements those, so just to again fit in well with the Kubernetes way of doing things. So quick comparison, right? So going back to OPA and Kyverno. So on the left is a OPA policy written in Rego. Rego is a language that the creators of OPA have created specifically for policy management. And it's powerful. It can do a lot of interesting things with processing JSON. But there is some learning and complexity, and it's not sort of declarative in nature like Kubernetes is, right? So on the right is the same policy written with Kyverno, and as you can see here, if you look through the some boilerplate in terms of matching resources, etc. But the last few lines of the policy will look very familiar to anybody who's looked at a pod spec or a deployment in Kubernetes, because it again follows the same, the same constructs, the same patterns, right? So what this policy is doing is checking that containers within a pod, have a security context, and that the read only file system setting must be set to true. Now, this is something that in most 99% of the cases, most developers don't even sort of need to know about or may not be concerned with. But if you don't specify this, you are kind of vulnerable to certain types of security hacks, which is why it's important, again, emphasizing where the separation of concerns, and for cluster admins, it becomes pretty important to be able to specify these sort of rules within policies. So the structure of a policy in Kyverno is, fairly standard, right? And we hope it's pretty intuitive to anyone, right? Because a policy just simply consists of a set of rules, and you can choose to group them however you wish. Typically, you will, just like if you're writing code, you will group related functions into a package or methods or whatever you're based on, whether it's an object-oriented or procedural or other type of language. So similarly here, you can group rules into policies. Each rule will have a match and exclude block, which specify, which resources you want that policy to operate on. And within those, there's a lot of flexibility. You can use Kubernetes kinds, names, label selectors, namespaces. You can select namespaces from, for objects which are already created, user roles, groups, etc. Right? So lots of different ways of choosing things. And then once you have selected if the policy and rule need to apply, you can, have the logic can either mutate, which means update or change the resource data. You can validate things, like you can enforce certain best practices. And with validate, you can either choose to block things right away, or you can choose to allow the resources to be created and then report violations to the workload owners. And then you can also generate, and this is a very interesting use case which is unique to Kyverno. So the thinking here and some of the lessons learned for us working with several customers is policies are not just about validation and enforcement, right? what you want to do is, I mean, the easiest way to think about this is it's almost like IFTTT for Kubernetes. So you want to say something like, if a namespace with label PCI is created, then any workload that runs in the namespace must have a node selector. And by the way, if it doesn't have, automatically inject a node selector with the label PCI in that workload, right? So Kyverno lets you do things like that and reach that sort of higher level of automation. Very simple example, of course, is with multi-tenancy, if you want to create namespaces. Other examples, even when this may be related, or applicable more to service mesh, when you're bringing up services, perhaps you want to, based on labels, based on annotations, and the creation trigger, generate a set of defaults or things like that. Another use case that we've seen with storage is when a namespace is created with the label selector, to be able to automatically create a backup schedule for something like Valero, right? So several examples being built in the Kyverno community, and would love to hear more about these type of use cases, which can combine the mutate, the validate, and generate behaviors to solve some user concerns. So in terms of how the machinery works, right? So Kyverno installs itself as an admission controller. So when you install Kyverno, and we'll go through that live, it's a pretty simple process, either through a Helm chart or through command line. And what it will do is it will install itself as an admission controller. It will generate a self-signed certificate. Then it will register with the API server. And what that means now is every API request that comes into the cluster will pass through Kyverno. And based on the cache of policies that you have defined, Kyverno can either validate, mutate, or generate configurations. And the outputs of that is either in the admission review response, you can block things if you just want to reject insecure configurations. You can also generate, policies will generate events if there's violations. There are policy reports that get created. And then there are, resources can get updated through mutate, right? So those are on the right side are some of the outputs of Kyverno. So once again, here's a simple, policy, definition, but, we'll look at a lot of this live. So I'll just kind of skip through this. And actually, let me pause there and just see if there's any questions. I saw some messages in chat, but let me see if anybody has any other questions or topics that they want to, or, on what I just went through. So I think there's one, just reading chat quickly, there was one question about whether it's a predefined set of rules for different workflows or different namespaces. So there are some, some policy libraries that we're creating in the community, but Kyverno is customizable. So you can, as a cluster admin, you can change this, you can define your own rules, and you can, apply those. So I think that's one of the reasons why, and I'm sure a lot of you have heard about some of the challenges with pod security policies, and the fact that they are going to be deprecated in version 1.21. So they're going to be marked for deprecation in 1.21 and then removed in 1.25. The reason there is because they were a little bit hard to change, hard to manage. Like policy engines like Kyverno make things a lot more flexible for users, for cluster admins. Any other questions before we, kind of go in a little bit deeper into what policies look like and see some live examples?
I see one Adina has like user role or groups can be integrated with Active Directory.
Yeah, good question, right? Because in Kubernetes, I think user roles and groups are typically a little bit, challenging to manage, right? Because Kubernetes itself doesn't have have a scope of users in itself. So Kyverno does not does not allow you to define users either, but you can manage user groups and user permissions. So the user object will still be in your central identity management system, whether that's AD or some other OIDC system. But what Kyverno can do is when it gets an admission request, the admission request will have the user information, and in that user information, it could either be a service account or a username which associates to a set of role bindings. So Kyverno can process that, and you can write policies based on which user is making a request. So for example, you might want to exclude certain rules for cluster admin, but apply them to users who don't have admin privileges. So that's something which is fairly easy to do. But the role itself, the user object, would still need to be defined externally, or you can use service identities or service accounts to manage the identities. Any other question?
Jim, in order to define policies, do you does that require a cluster admin privilege level, or yeah?
So Kyverno supports both cluster level and namespace level policies. So for cluster level, typically it would be a cluster admin and you can configure this through RBAC. But it would typically be a cluster admin who would configure cluster level policies. Now, it doesn't have to be the Kubernetes, cluster admin, which is just a star type of role, which allows everything. But it needs to be a privileged role that can operate at the cluster level. If you have a workload owner and you want to create policies only for a specific workload, you can create them at the namespace level.
And those, if you're going to get to this, don't answer it. But just to follow on that, are those? Is there some inheritance there with respect to?
Good question. No. So the policies are designed to so that you cannot override or change something at the namespace level. So if you define a cluster-wide policy, it applies to all namespaces or based on the filters you define in the policy itself. So you can exclude certain namespaces, you can match others, etc. But you cannot override. So it's like an and of all the policies. You cannot change the behavior or override the behavior of a policy defined at the cluster level. But you can add to that and further extend the behaviors by defining new rules, new policies.
Makes sense. Sounds like you're like this is like there's a security mindset to this. What's going on with that?
Yes, no, very much so. And one of the first examples I'll show is how to, if you're not using PSPs, of which a lot of folks, because of the challenges of PSPs, tend to not use them. I'll show how simple it is to enforce pod security with Kyverno. Yeah, the other question I see here is, will rules consider dynamic changes? So yeah, that's a great topic. So the rules can be data driven. And in fact, actually, let me pull up a more, I'm going to go to the Kyverno docs. And in fact, we'll follow that, just even for installation, etc. But what I want to show is if you dig into writing policies as you're kind of doing things, there's a whole section on variables and data sources, right? And the idea behind variables is to make, just like the question is asking, to make things dynamic and data driven, right? So there are predefined variables that Kyverno parses and populates, like service account names. There are variables coming from the admission review request. So things like the namespace the object is operating on, etc. And you can also like look up things within a policy, like this example is just looking up, and making sure that the readiness probe and the liveness probe, are, kind of, I guess it's It's just checking that it must be the port number that must be less. Like, I don't know why this would make sense, but if you want to, you can do things like this. Um, so the more interesting example is if you want to kind of look at the request operation and make sure that, if you just want to operate on updates, if you want to look at the object info that's being changed, all of that can be, used as templates. Here's an example of a username. So lots of different ways of driving that. In addition, for more advanced policies, Kyverno can fully leverage config maps and other external data sources. So one data source, which is, of course, in Kubernetes, everything is driven, if you want to configure your services, you would typically use a config map. Similarly, the approach we have taken is we've made config maps native to policies. So you can look up so let's say there's a config map defined here. You can then use it as a dictionary within a rule and use that now in a variable format to say, okay, my environment name, perhaps if it matches a certain namespace, has to be, I'm going to pull it from that dictionary. So you can even nest these variables to kind of do a double lookup, or a nested lookup to make sure that you're getting the right value, right? So this, for example, instead of env, could be the namespace name of the object you're operating on, which will pull up the value that you want for that environment variable. So yeah, lots of flexibility there. I also see there's another comment on wildcards. So with namespaces, names, yes, Kyverno supports wildcards. So that's a pretty handy feature, because then you can start kind of having some naming conventions, which will like you could say every namespace that starts with dev, right? And you say dev dash. So I am going to enforce. In fact, you can even enforce that and say that if a cluster admin is not creating a namespace, it must have a certain prefix or suffix or whatever you wish. All right, so let's dive into some actual policy examples, right? So I have a few in the slides, but let's just go to command line and run a few policies. So I think I had a shell up and running, but maybe I closed that. So let me first check and see if I have Kyverno installed, or I think it may already be running. And if it is, we'll just remove it and reinstall it, right? Because I just want to show you the full experience. So I'm going to go back to the docs and just go into the introduction. And just in the quick start, there's a one, it pulls the YAMLs. If you're using this for any, if you're using it for a test cluster like we are, this is perfectly fine. If you're using it in a, there's a production cluster, you may want to also look at the Helm chart. The Helm chart installs some default pod security policies. There's options to turn it on and off. So if you go to, in fact, I think it's on Artifact Hub. There's a Kyverno Helm chart. You can kind of look up all the settings there and just follow that. In terms of installation, right? So pretty straightforward to do, and there's a lot of different things you might want to tune, which you can configure here. But going back to what we want to do for now, just a simple way of getting Kyverno up and running. So I'm actually going to just do a delete first, and then we'll reinstall it and bring that up. So this will pull down the YAMLs and delete everything, and all of our policies. So we start clean. And let's make sure the namespace is gone. Okay. Sometimes it takes a while to terminate, but now I'll go back and just create. And once I create or apply these YAMLs, it will go ahead and recreate everything, right? So as you can see, there's a bunch of CRDs it's pulling down. Some of these are internal. Some of these, as you'll see, is like more user-facing things. It also installs a webhook. And there's different roles and role bindings that will create. And then finally, you can see here there's a deployment. and a service, right? So if we now go back and let's look at the namespace, we should see that there's a pod running. It's still coming up, it looks like. So it may take a few seconds to initialize. Okay, there it goes. So now it's running. And you see that, okay, so if we look at the logs, we should see that it's registered the webhooks, the certificates, all of that, right? So at this point now we're ready to, there's no policies, there's nothing that I have in this cluster. But what I'm going to do is we'll just go to that example we talked about pod security, right? Because that's something that's a pretty hot topic these days, as with all of the changes coming in. So I'm going to go in the Kyverno documentation. I'm going to go to this policy section, and we'll go to pod security here. So policies, we have pod security policies, we have best practice policies, which are just general, nice to haves. And then we have other policies, which are in here. So once you go to pod security, what it says is these policies are based on the Kubernetes pod security standard. So if you haven't seen this, I suggest, this is good to go look at these pod security standards, because it's a great way to organize and think about, different security levels when it comes to when you're applying these to workloads, etc. So here, and there's 3 different levels defined in this pod security standard. So this is in the official Kubernetes docs. There's privilege, baseline, and restricted. And privilege means everything's allowed. Baseline is just the defaults. Restricted is I want to run, a secure production type cluster. So what I'm going to do is I'm actually going to go for restricted, right? And I'm going to just copy this one liner, which is telling me it will install all the pod security policies. So if we go back to our command line, we'll just run customize and apply that whatever customize is pulling. I'm trusting it and applying it to kubectl, right? So this takes a few seconds because it pulls down a bunch of YAMLs. And once that's done, I see now I got a bunch of different policies. If I go into my command line again and do, get CPOL. CPOL is short for cluster policies. And I just do -A. I will see I have a bunch of security policies. And the interesting thing is they're set to enforce, right? So with Kyverno policies, you could set them to either audit or you can set them to enforce. If you set them to audit, it will just produce policy reports. If you set them to enforce, it will actually block things and reject workloads from running. So at this point, if I try to run a workload, and one example which is fun to try is there's this website called Bad Pods, and it's by the security group called, I think they're, it's Bishop Fox. So they have published a set of things that you could things, pods which allow bad things to happen, right? So things which you should not have in your production cluster. Like this one says, and again, this is fun to go through and understand, but this is running a pod with all doors wide open, as is visually shown over here, which is pretty bad, right? You shouldn't be doing this in any cluster because it allows a lot of bad things to happen. So now to get to the YAMLs, what I'm going to do is just grab this YAML as it shows. And then, by the way, there's actual instructions for how you could now, use this pod to create or to get access to host, which once you have access to host, of course, and if the pod's running as root, you not only have access to host, but you're root on the host. So again, not a good thing. So let's see if Kyverno and the policies we installed actually help us with this, right? So I'm going to run this very bad pod on my cluster, and immediately Kyverno came back and said, no, can't do this. And it's telling me exactly why it was blocked for a host IPC, can't run it with that namespace, can't run as root, can't run as privilege. So it's just blocking everything that I tried to do, right? So that's extremely simple, and of course, there's a lot of details to understand before you run this in your cluster, but just gives an example of how easy it is to, with Kyverno, to, sort of have a fairly flexible replacement to, pod security policies. If you look at some of these policy details, and, we can kind of either pull up a few YAMLs and go through those, and I have some even as examples. So let's actually, let me see if I have an example, but yeah, this is adding a label. This is blocking a request. I want to search for an example. So let's look for root. Yeah, this disallow root, right? So pretty simple example, but what it's doing here is it's checking and making sure that you can't run as user with GUID or group ID 0, and you have to set other specifications in your for your pods itself. Now, if you want to, so one of the other interesting thing is, these policies are written at a pod level, right? But let's try to do something with Kyverno. I think I have, even though I applied all these policies at the pod level, I want to run a deployment and see what happens, right? Because I don't want to rewrite all these policies for each pod controller, and there could be other pod controllers which are custom resources. We don't want to deal with all of that. So what I'm going to do is I think I have a Nginx or something. So I'll just create that. Okay, so this one, I believe, I'm pretty sure it's a deployment. So I'll just do nginx.yaml and see. Okay, good. So that got blocked too. And the reason why that happens is Kyverno automatically generates rules for pod controllers from policies that are defined at the pod level. And you can, of course, control all of this, through annotations. You can restrict the behavior. In fact, if we go back to the Kyverno docs, there's a whole section on this in the autogen rules when it comes to writing policies. So you can go in here and see how you can restrict and manage this, and what problems you can solve. So the idea basically is you write a policy on a pod, Kyverno explodes it out to the standard controllers, and you can add more controllers if you want, right? So this is just a simple example of how Kyverno can leverage Kubernetes patterns, Kubernetes practices, and make things simpler in terms of policy management. All right, so one other quick example I want to give, and then we'll kind of do some Q&A. And so I want to show how you can generate things, right? So I'm going to write up, take a policy. This is a pretty simple policy, which we'll just grab from here, which whenever a namespace is created, and it's excluding some namespaces, but it's also going to clone some resources, which I could either have defined upstream, or I could define inline in my policy itself. Actually, let's grab this one, right? So we're going to say I'm going to create a network policy for each namespace, a default network policy, but just denies all by default. So let me first check and see if I have that. If I have that in here, we'll just use that. Okay, good. So we have that in here. It's add network policy under best practices. So let's just apply that. And I think it was add network policies. Yeah. Okay. So if we create that policy, and now if I create a namespace, what I expect to happen is that network policy also gets created, right? So I'll just create a namespace called test. And if we do -n test, get network policy, what we should see is that default deny is created, right? And this was what the policy probably called it. One interesting thing is, if I delete that, so if you notice right now, the timestamp is about 12 seconds. If I say delete, depending on whether the policy had said it should synchronize changes or it should, allow users to update things, you can control whether Kyverno will recreate this or it will, or it will just block this, right? So actually, I need to say delete network policy default deny ingress. So let's see what happens there. Okay, so it deleted it. And if I do get network policy again, what I would expect to see is it got recreated and it's a newer one, right? So we actually, in Kyverno, we don't block the delete because of certain, the way admission controllers and RBAC and other things work, but it'll automatically just recreate it. And this is a good way if you want to get back to defaults, you can just let Kyverno just recreate it as well. All right, so I know we're just 7 minutes to the hour, so let me stop there. We went through some interesting use cases. There's a lot more in the documentation. So I'd love for everyone to just try out Kyverno, install it, play around with some of the policies. We're fairly active on the Kyverno Slack channel too, so just join us there. Take a look at the GitHub, just ask questions, right? And we're always creating new policies, adding things. So what would be awesome to hear from folks is, just ideas on what type of problems Kyverno can help solve, and things where it may be a good fit in your domain of expertise at the service mesh layer. So any questions, thoughts, feedback?
Boy, it's really hard for me to bite my tongue, Jim. I have so many questions for you. I'm trying to be quiet because I know I've gotten a number of comments from others on the call who are just digging what you're laying down. So I know they've got some questions.
Yeah, and I'm sure, so feel free to put things in chat or just, we can, and things will come up, of course, later too. So Slack's a great way to reach out. But Lee, if you had anything right now, we could either answer
Okay.
or.
Okay, good. Yeah, let me, well, let me express this in a way in which you can educate us all, including me. So, which is to say, at the core, Kyverno, like any other policy engine. It was nice that you characterized Kyverno in contrast to other policy engines and sort of what makes Kyverno unique and quite useful in a Kubernetes environment, particularly, or especially. Of the So while Kyverno does at its core, evaluations
Mhm.
and policy are you'd mentioned like the results of those they can be thumbs up, thumbs down. They can also be like, and I don't know that you probably wouldn't characterize it as a thumbs up or thumbs down. You'd say like, hey, there's also this a mutate or the ability to like, hey, this is interesting. It's not a thumbs up, thumbs down necessarily. There's some respects it's a match,
Right.
and so then from there, I know you said it in your slide. Can you articulate it again? The potential, the 3 or 4 different types of
Yeah.
actions?
So you can mutate things like you mentioned. So you can add labels, add defaults to a resource. You can even generate things, right? So if you want to trigger based on an object creation or a label creation or a label change, you want to trigger like some dynamic behaviors. And those come down to like generating resources or deleting generated resources. So those are the types of triggers. So it's mostly through admission controls, but also, reacting to certain objects being created or labels and annotations being changed.
Makes sense. And there's no concept of a scheduler within Kyverno, is there? Is it just all
There is a background scan, so it will periodically scan, the all of the configurations. And Kyverno is designed so it does not impact existing workloads, right? So it won't take down existing, workloads, right? But it will periodically scan and report things it finds. And that creates, by the way, one thing I should have shown is a policy report, right? So you can kind of look for examples for that in the docs. But Kyverno will produce a policy report in the namespace, in each namespace, with any violations, things like that.
those reports then are stored in one of the custom controllers or in the custom?
It is a resource itself, right? So it's a Kubernetes resource. So you can fetch it through kubectl. You can, then use any other tool to, be able to propagate those reports upstream. Like Nirmata collects those reports, and we will display them and show more information, things like that. So in fact, the policy report is something we're working with the policy working group and standardizing so other tools can also use that. So the idea is independently of which tool is producing a policy violation, having a standard way of reporting it and managing it.
In terms of like multi-cluster concerns or multi-cluster environments, what changes, or if anything?
So certainly ensuring that policies, the right set of policies are deployed to each. So one nice thing about, Kyverno policies is you can use all of your GitOps best practices to manage Kyverno policies, right? They're just resources. You can apply customize like I demonstrated. All of that just works really nicely with existing tooling without having to, kind of change the way things are done just to fit in policy management. But yeah, for multi-clusters, you would either use like a multi-cluster manager like Nirmata or GitOps or, by the way, the Flux project also bundles now Kyverno policies for multi-tenancy. So that's another open source project we're collaborating with. And so that, because Kyverno is just so lightweight, it can be embedded into other projects for some standard behaviors and policies, eliminating the need for more controllers, more custom logic.
I've got 19 more questions, but I'm gonna hold them off.
Oh yeah, let's follow up. And I see, also Adina also commented on, more features for like going in deeper into validate and mutate. So yeah, absolutely. I think, just combining, and I have some other examples which we're using for multi-tenancy. So triggering based on object creation and then combining validate, mutate, generate is where the power really lies. And there's some pretty interesting things that can be done. So maybe we can follow up with some offline threads and conversations. Just post your ideas on the Kyverno Slack and or just reach out to me, however you wish, and would love to explore that.
Vijay had a quick one, which was when a policy is modified, when does it take effect?
So the policy, of course, as soon as it's updated, will take effect right away for any other subsequent admission control, right? But for existing resources, again, the way Kyverno is designed is it doesn't go back and it won't impact existing resources. So there it will produce violations if needed. And it will, like if you change anything in that existing resource, it will then start reporting or show that the new update. But as soon as you save the policy, it takes effect in, from the perspective of any other subsequent request or anything coming in through the API server.
I have to do this. I got one other one I want to insert in here real quick. Of the criteria that a policy can reason over, like the various constraints, the various things that would determine a match or that would determine the outcome of the evaluation, is it possible for that criteria to be from systems external to Kubernetes, like from a database, for example?
Yeah, good question, right? So we don't allow in Kyverno calling external systems, and we've specifically designed this to be a closed and kind of secure system, right? But you can use config maps to achieve that. So the idea would be if you want an external system, so let's say some other system is producing, a good example is, you want to make sure that the image name and tag matches the hash in your, let's say in your upstream image registry, right? So for something like that, you could have a periodic job in Kubernetes which fetches the hash from your image registry, stores it in a config map, and then you could use that in Kyverno, right? So that would be the pattern, almost like using a sidecar pattern, but think of it as a sidecar controller, right? Where you're writing a separate controller which does that one thing, produces the data inside the cluster securely, and Kyverno can consume that.
How dare you pull a judo move and bring in sidecars on us like that?
Yeah. Hey, service mesh sidecars, right? So, right.
Well, it's actually kind of funny because, well, like technically, like while sidecars get mentioned a lot in context of service meshes, like
Right.
it's a generic concept too. Like it's not a service mesh doesn't own it, but yeah. Jim, this is fantastic. It looks like you'll probably have a couple of folks jumping into Slack with some questions. For my part, I've got I'll hit you up.
All right, sounds good. Well, thank you, everyone. I know we're a little bit past time, but really appreciate having me here, and would love to hear from everyone in the community.
Nice. Oh,
All right,
thank you for coming,
take
Jim.
care.
This is great.
Bye.
Yeah. See you guys all next week.
Thank
Bye.
you.
Bye bye. Thank you very much. Bye bye.
Hi, everyone.